Alright, let's look at the practice exam 1, problem number 9, part B. Alright, let's evaluate this improper integral. Alright, this is improper because there is an infinite discontinuity in the integrand. Alright, so let's do a substitution here again. So I'm gonna let u be the expression inside the square root. So in this case, just x minus 3. Right. So you can see that when x equal to 3, the denominator becomes 0. So that's the infinite discontinuity. So I'm going to let u be x minus 3. And then take the derivative of u with respect to x. You get derivative of x is 1, derivative of negative 3 is 0. Alright, so in this case, let's say I'm going to just take the reciprocal so that it's consistent with what we have been doing. But reciprocal 1 is 1 anyway, and then multiply through by du. Right, so we found out that the dx is actually exactly the same thing as du, so they are interchangeable. Alright, then lower limits and upper limit. So x goes from 3 to 12. Right, then corresponding u values would be 3 plugged in here. 3 minus 3 is 0, so u starts from 0 to 12 minus 3 is 9, right? So it goes from 0 to 9, right? So let's rewrite this integral, right? So this is going to go from 0 to 9, right? And a 1 over square root of u, right? Dx is the same as du, so we can just replace it by du, right? So that way we could rewrite the integral just in terms of u. Alright, so in this case the troublemaker would be the lower limit, because when u is equal to 0, the denominator of the integrand becomes 0. Right? So what we need to do is we're going to use, instead of 0, I'm going to put some maybe positive number a, right, to 9. Then I don't like the way it's written, so I'm going to rewrite that as u to the, so u is sitting in the denominator, so it's got to be a negative power, and the square root is 1/2 power, right, and the du. Alright, then since a has to go to 0, so we're going to take the limit, so we take the limit. And as a approaches 0, and this approach from the positive side. Right? Right, so let's find the antiderivative. So this is going to be equal to, right, we still have the limit as a approaches 0 from the right. Right, so antiderivative of this guy would be add 1 to the power, so u to the negative 1/2 plus 1 is positive 1/2. Right, divided by 1/2 is equivalent to multiply by 2. So actually, instead of having a 2 here, I'm going to actually put the 2 in front, since it's just that's the constant. And then this is just going to go from a to 9. Right, and also remember that 1/2 power is equivalent to square root, so this is actually just a square root of u. Right, so this is going to be so 2 is just a constant, and we're going to take the limit as a approaches 0 from the right, right, and plug in 9, so you're going to get square root of 9, so that'll be 3, so it's a square root of 9, so it's 3, minus square root of a. Plug in a for u. That. Right? Then as a approaches 0 from the right hand side, you can see that the square root of a is going to approach 0. Right? So therefore, limit of 3 limit of 3 minus square root of a is going to approach 3. So we have a 2 times 3, so that would be 6. Right? So that's the value of the improper integral in part B. Right? That's it. I hope that this was clear.